A big topic in AP statistics that deals with significance testing is power. We all love power and we crave power, but let's talk about exactly what power is. So when you have a null and an alternative hypothesis, like I do here, power is when the alternative hypothesis is true and our p-value tells us that, our conclusion tells us that, and we actually conclude that. So again, power is when the alternative is true and we make that conclusion. This is the complete opposite of type 2 error. Type 2 error is when the alternative is true, but we actually fail to conclude that. Again, that's a mistake. Power is a good thing. So power is the complete opposite of type 2 error. But how do we get more power? How do we get more power? Well, the first way to get more power is to increase your sample size. That should go without a whole lot of explanation. Bigger samples vary less. So a bigger sample is always going to give us a more accurate reflection of what's really happening. No sample proportion is going to match the population proportion perfectly, but a bigger sample should get us there. So if the truth is that the true population proportion is greater than 17%, a bigger sample is going to more likely show that to us. Bigger samples increase power. The other way to get more power is to increase your alpha. What? How does that make sense? Well, let me show you. So alpha, let's typically say, is 5%. This means, in this particular scenario, this is a one-sided upper test. That means the top 5% of samples are what's going to tell us to reject, right? That's going to be our rejection zone. Now, the top 5% is a z-score of 1.645. That's that top 5%. So this would be our rejection zone. Anything up here is going to tell me to reject the null hypothesis and go with the alternative. Now, if the alternative is true, then yeah, I want to reject. So that's good. That's what I want to happen. Now, think about if we were to instead use a lower alpha value of 1%. Now, an alpha value of 1% means that only the top 1% of samples are going to force us to reject. That is a z-score of 2.326, I believe. So that's going to essentially shrink our rejection zone. And if we're supposed to reject because the alternative is true, that actually means rejecting is going to be less likely. So if we use a larger alpha, that will make our rejection zone bigger, hence we'll reject more often. And if the truth is that we're supposed to reject the null because the alternative is true, that's going to give us more power. So again, bigger sample size, bigger alpha are all going to give us more power. One more way we could get more power is this. Now, this is kind of out of our control, but it does make sense. And that is if the truth is way more than 17%. Now, for example, let's say that the truth is 19%. Now, no doubt about it, 19% is greater than 17%. And if the truth is 19%, which is greater than 17%, I hope we would reject the null and go with the alternative. But the problem is 19% is like only a little bit more than 17%, so it might not be so easy for me to see in a sample. Whereas if the truth was, let's say 45%, a proportion of 0.45, that is so much greater than 17% that a sample should definitely show me that, causing me to reject. Because if the truth is 45%, that means my whole model should actually be way up there because the center is not 17%, it's obviously way more. And that means more samples are going to be way up there, which means I'm more likely to find a sample way up here in my rejection zone. Now, unfortunately, I cannot control what the truth is. I can't control my sample size. I can't control alpha, which are going to give me more power. But having a true proportion way greater than the null, or less than if we were looking at a one-side lower test, hopefully that makes sense, then that would also create a test with more power. But at the end of the day, power is a good thing. It's rejecting the null that's wrong and going with a true alternative hypothesis. Hopefully that makes a lot of sense.